Welcome back to your favorite pre-calculus class. It's good to be here today, of course, with you guys. We're going to look at we're going to finally get into trigonometry, trigonometric functions in this section, and more specifically, radian and degree measure. Okay, radian and degree measure. Now, this as we get into trigonometry, trigonometry means is derived from the Greek language. Measurement of triangles is what that means, and it's used in astronomy, navigation, surveying, um, calculus. There's different approaches to trigonometry. One is the unit circle approach, which we look at the unit circle approach in this textbook initially. There's also a right triangle approach. Maybe I can show you guys that my green book that I used to teach from it over at the college, and that's a right triangle perspective to trigonometry. You can use either one to approach it. We do both in this. We're going to start out with the unit circle approach, and but we're gonna look today at there's a whole bunch of vocabulary that we need to look at, some of which you guys are familiar with from your geometry courses. But here, let me get this wire out of the way. Okay. All right, let's talk about first of all an angle. An angle in trigonometry is a little bit different than a static angle in geometry, if you will. In trigonometry, you rotate an angle. So you have this, draw it here. You have your initial side, you have your initial side, you have your terminal side. So the initial side, of course, is terminal. Initial side is where you start, terminal side is where you end. Right here is your vertex. Okay, and we rotate. Okay, and we rotate in the positive direction is counterclockwise in trigonometry. So we rotated that thing counterclockwise, and of course you got your angle in there. It's by how much you rotate it there. You see the little arrow. So that rotation creates an angle. And we also have standard position. And standard position is when your initial side, if we put this on a Cartesian coordinate system type of deal, so we have it, well, we have horizontal and vertical axes. We put that vertex right there at the origin. Let me do it in red. The vertex right there. We put our initial side to start out right there, right along that x-axis, if you will. And then we rotate, and if we rotate positive again, it's going to go counterclockwise, and there's our terminal side. Okay, this is standard position. This is standard position when you start there, your initial starting point, your vertex at the origin, you start right along there. Okay. Now, if you go again in this is a positive. This is a positive angle here. Now, if you actually had your initial side, again, starting in standard position, and if you rotated this clockwise, like let's say you went to here. Okay, so you started here, do black here, started, and let's say you ended, so you rotate to there. This is a negative angle. This is a negative angle when you go clockwise, okay? And of course, this would be your terminal side here, okay? So that is the negative direction, so your angle will be negative. You know, that looks like an angle of, I don't know, maybe negative 120 degrees or something. Okay, and then you have coterminal angles. And coterminal angles are when you have the same initial and terminal sides. Okay, so let's say we got this axis again, and let's say we rotate, we start in standard position, okay, and we rotate positive direction to here. And let's call this angle alpha, however much that is, okay? So coterminal angles mean they have the same initial. So let's start another one in standard position, and it's going to go to the same terminal side. So this, let's call this angle beta, however much beta is. Okay, alpha and beta here are coterminal. Alpha and beta are coterminal angles. Those are coterminal angles. So start at the same spot, end at the same spot. Okay. Now you don't have to have one going in the positive direction, one going in the negative direction. Like you could have coterminal angles. Um, start here, and let's have one go to. Let's just have it go that amount. Okay. Let's have it be alpha again here. Okay. Now let's draw a coterminal angle. A coterminal angle that starts at the same place and ends at the same place, but is also positive. Okay, so it goes the same direction. So we've got to start here, same initial side, and we have to end here. Now, how's that going to work if it's not the same one? Well, what you can do is you can rotate around, so there's 360 degrees, right? So you make one full revolution, but you got to stop at the same spot, right? Because you have a same initial side and the same um, terminal side, right? So you have this beta, which is definitely more than 360 degrees, right? That alpha and beta there are coterminal, okay? Alpha and beta coterminal, right? Now, let's get into a little bit into radian measure, okay? So, first of all, the definition of a radian. Let me let's see here. How do I? There we go. Okay. Go new screen. Definition. Okay. So one radian, you guys, is the measure of a central angle theta that intercepts an arc S equal in length to the radius R of the circle. Okay. So let's talk about that. Okay, theta over R. So we got this. Let's see, we got this. Circle. Okay. So 1 radian, okay, is the measure of a central angle theta. Okay, so let's say, so we have this central angle theta. Okay, so we've rotated theta amount, right? That's your central angle there, your theta, and it intercepts an arc S, an arc S. So let's say, so how much did we intercept as we've rotated? See how we've intercept as we've rotated this thing from our initial side, we've rotated this around. You see how we intercepted this circle, that amount, S amount, okay? That is your arc length, and that S must be exactly equal to R, your radius of this circle. You see R right there, okay? So if you see how if you're looking over here, this is our central angle. Central angle. S right here is our arc length. I guess I should have drew that in green there. R is our radius, right? R is our radius. Okay. So you see how in our circle, if I draw this so that my S, however much I've intercepted this circle, if that S amount is exactly equal to my R amount, so S over here equals my R. Well, if they're exactly equal, let's say it's a radius of 2, so my S also intercepted 2. Okay, let's say it's 2 centimeters and 2 centimeters. Let me draw that in. Let's imagine this to be 2 centimeters. Let's imagine that to be 2 centimeters. Okay, then our theta would be 2 centimeters over 2 centimeters. And guess what we got? Theta is 1, and we call that a radian. And this is unitless. This is actually pretty cool that you can measure an angle and it's unitless. So theta equals 1. We just call that a radian. This is in radian terms. It's a real number. Theta equals 1. Okay? And let's continue on here. Let's talk about things that you know with circles. Okay? So let's imagine, you know how the circumference of a circle is 2 pi r, correct? Okay, the circumference, you have a circle, and we know that circumference of that thing is 2 pi r, right? You got r being your radius again here, okay? Well, to make one full revolution, okay, so your arc length, if you were to go around, right, one full revolution, your theta, right, you go around one full revolution. Well, how much are you intercepting along the way? If you take this thing and you're rotating it around and you're intercepting, so I'm intercepting this, intercepting, right? How much do you intercept? Well, that's your circumference, right? Your arc length is 2 pi r, okay? So what happens, your arc length, okay, ends up being, so your 2 pi is your theta, isn't it? Theta, that's your central angle times r, the radius, right? We intercepted, so our central angle, okay, our central angle here is 2 pi, and our circumference here is s, okay, the amount of the arc length. Okay. Another way to look at that, think about over here. If you have theta by definition s over r, right? Well, you multiply this by r, multiply this by r. So s, and let me flip-flop those. S equals r theta, or theta r. S equals theta r. So if you were to write that over there, s equals theta r. Do you see how 2 pi must be your theta? Okay, 2 pi must be your theta. So think about that. You know, your central angle for one full revolution is 2 pi. Okay, so you know the same as 360 degrees. Theta equals 2 pi, your central angle, for one full revolution. You know, you've talked about, i.e., you know, that's 360 degrees before. If you're talking in a unit measurement, you know, being degrees being your unit there. So theta equals 2 pi for one full revolution. So what about for a half a revolution? You know, if you're to think about a half revolution here, let me get a new one. Okay, if theta equals 2 pi, one full revolution. If I'm going to go all the way around, theta equals 2 pi, 360 degrees, right? Well, what would half of that be? What would a half a revolution be? Well, you're like, well, that's got to be 2 pi, half of that, divide that by 2. Theta would be pi for a half a revolution, okay? So if you're just to go to here, how much did you rotate? Pi amount. How much is that? I mean, if you're to think about in terms that you've dealt with before, you know, that's 180 degrees, right? What about for a fourth of a revolution? A fourth of a revolution, so 2 pi divided by 4. 2 pi divided by 4. 2 pi divided by 4, right? Oh, that's pi halves. So that's a fourth revolution. In other words, 90 degrees. So if you go right to there, pi halves. Trying to remember that. Looks like I'm hitting my little 15-minute mark here. I'm going to stop right there and continue on.